Hi, welcome to the one and only video for section 3.2 for Honors Algebra 2. This section is officially focused on the ideas of domain and range, but we are going to spend a little bit of time talking a little bit more about function notation, which we started working on yesterday. So this first slide is the idea of function notation. If you remember from yesterday's video, it's basically in an ordered pair, instead of thinking as y is y, you think of it as a function of your x value. So we call it x comma f of x. So it's basically that y gets replaced with an f of x, so you know you have a function. So these things here that we're looking at are some different ways to read function notation. Some seem more obvious to me than others, so just get them written down and then I think you'll be fine. So this right here, where in parentheses it says f plus g of x, that should be interpreted as f of x plus g of x, and I'll do an example of that later. This next one, in parentheses, we have f times g of x. That's where they want you to find the value of f of x, find the value of g of x, and multiply them together. Maybe you're seeing the pattern. This third one, f minus g of x, is actually saying we want the value of f of x, we want the value of g of x, and we want you to subtract f of x minus g of x. Then this last one, if you're guessing division, you've guessed correctly. You would take the value of f of x, divide it by the value of g of x. These would be worth to have in your notes today, just so when you see that type of notation, you know what it means. And here should be an example, okay? We have f of x is 2x plus 1. G of x is x minus 3. And here they want you to find f plus g of x when x equals 5. Well, okay. So, I kind of remember that that's f of x plus g of x, and they're telling me that x equals 5. So I could rewrite this as f of 5 plus g of 5 if I wanted to. There are a couple of options on how to do this, and I don't really know what students prefer. Usually every year I get kind of an even split. So in this video I'm going to show you both ways students tend to solve this. Lots of students will say, okay, well f of 5 means I rewrite this equation because that's the f of x equation, but every time I see an x, I replace it with a 5. All right, so f of 5 must be 11. That's fine, but then we have to do g of 5. So g of 5, now I'm going to use the g of x function. Every time I see an x, I plug in a 5. So g of 5 equals 2. So then to put everything together, since it was asking me for f of x plus g of x, or basically f of 5 plus g of 5, that's basically, well, f of 5 we found to be 11, g of 5 we found to be 2, so our answer is 13. That option works great, where you individually find f of x or f of 5, and then you individually find g of x or g of 5, and then it's not till the end that you combine them together. Option 2 just takes a little bit of a different approach. Again, you decide which option you like better. This would say, okay, well f of x plus g of x, well f of x, I lost what it is. F of x is 2x plus 1. And then I'm going to add g of x, which is x minus 3. And before I put any numbers in it, let's combine like terms. 2x plus 1x is 3x. 1 minus 3 is negative 2. And if it wants to, then what you would do at the end is replace the 5. You also land at that 13. So you can see that the answers match up, whether you work individually and then add them together at the end, or if you combine the like terms and then put the 5 in later. That's really up to you, personal preference on what you like the best. All right, now let's talk about domain and range. We hit on it just a little bit in chapter 1. So as a review, a domain lists all the possible x values, and the range hits all the possible y values. And all this slide, this is the last slide of the video, all we're going to do on this last slide is show you that there's different ways to write about domain and range, and I want you to be familiar with them both. So in this example, I look, and when it asks about the domain, it looks like domain, remember, x values, we're looking left to right. So the farthest left it goes is -2, and the farthest right it goes is a +4. So some people might say they say D for domain with a colon, and they say, well, the x values are greater than or equal to 2, but less than or equal to 4. And that would be an appropriate way to write the domain. The range, R with a colon, well, the range are the possible y values. So you're looking up and down this time. So it looks like the lowest the graph gets is y equals 0, and the highest it gets is up at 3. So the range is the y values. It's greater than or equal to 0, but less than or equal to 3. So notice I wrote the range from left to right was I went from the lowest to the highest, where the domain, it's a little more obvious, I wrote it from left to right. That is one way to write the domain and range. Another way that you will get be exposed to is saying, okay, the domain, oh, and this should say -2, I believe. Sorry about that. The domain says, well, at the farthest left, the lowest amount is -2, the highest amount is 4, and we put brackets around that because it's a solid stop. It will not go less than -2. It will not go bigger than 4. If we follow that same type of notation, the range would have, well, the lowest down it gets is 0. The highest up, the y value gets is 3. I'm going to put those solid brackets around it to show it will not go below or above that. So you can get used to writing the domain like this or like this, and then the range like this or like this. You will see it both ways in this class. So it'd be good to have both written down, along with a sketch of the picture. All right, now this picture is a little different. It says y equals g of x, so I know it's a function by function notation, and visually I know it's a function. It would pass that vertical line test. All right, so one way I could write that domain, I'm thinking left to right. It looks like the farthest left it gets is -6. The farthest right it gets is 5. So I could say the domain, x is, or 6 is less than or equal to x, and x is greater than or equal to 5. So it's from left to right, smallest to biggest. And then the range is saying, okay, the lowest it goes on the y is -2, and the highest it goes is 4. So the range is between -2 and 4. So I could write it like this. If I wanted to do the other way that I'm used to, I would write the domain, I'd have that solid bracket, -6, 5, and the range would also have solid brackets of -2, 4. All right, well, what happens, like, how would you write this if instead of a visual picture, they gave you something like this, where there's not a continuous graph, it's just discrete points. Remember, these points could be rewritten out as 1, 1, 2, 3, 3, 4, and 4, 2. Well, what I would do in that sense, because it's not continuous, this reads it goes between -2 and 4, and this picture would only have points. So how you would write it this way is the domain, you use these squiggly lines, I don't know why, and the x values are 1, 2, 3, and 4, using the squiggly. You don't have to put them in order from least to greatest, but generally that's what people do. So like, what are the range values of these points? They're 1, 3, 4, and 2, and lots of times then they'll write them in order. So they would be 1, 2, 3, and 4, but you don't have to do that. Okay, so that's how you would write domain and range if you don't have a continuous function graph, it's a discrete one. All right, this next one, I want you to sketch it in your graph a little, we're gonna change it a little bit. I'm gonna put arrows on each end. Actually, let's just put an arrow on the right-hand side, and I'm gonna kind of fib it a little bit by putting a dot right there. So it's a little bit off, okay? So now let's think about this. How can we write the domain? We've got two options. Domain is left to right. Well, it looks like from left to right, on the left, it won't go lower than -3, but what's happening on the right? That arrow means this is gonna go up and out forever. So it never, the domain will never stop on the right-hand side. So I could say this is that x has to be greater than or equal to -3, because there is a boundary on the left, but x is gonna be less than, it's gonna really go on to infinity. And that looks kind of weird to me, so I personally prefer the other type of notation where we'd have a solid bracket here at -3, but then I'm gonna have an infinity, and what they do is more of a soft parentheses curve to show that infinity, it doesn't really have a bracket on the right, it goes forever. It could, the domain could go forever. Where the range here, let's think about it. How low, what's the lowest y value we can have here? Well, it looks like -3. Again, that was kind of a coincidence. And then what happens to the y value? It will never end. There's no restriction on how high up this can go, so you have that infinity again, which looks funny to me. So I would do that solid -3, comma, infinity, where I had that strong square bracket on the left, the smooth one on the right. All right, last one of the day. This is, I think, my favorite one, so don't quit. If you're kind of getting tired of taking notes, keep going. I have my x and y axis, the origin down here, and then there's a nice squiggly line or curve from left to right. It's not ending. Let's put arrows on both sides, but it definitely looks like there's a boundary on the top and a boundary on the bottom. So I look at that and I think my domain is unrestricted. From left to right, it's gonna go on forever, where up and down, it's gonna stop. So my domain, I'm gonna say, I'm just gonna write it. Some people would say the domain is all real numbers. Some mathematicians use a shortcut of it, like it's a, I don't know, it looks like an or a T with an R connected, which stands all real numbers, which basically means there's no restriction. I think the thing that makes the most sense is using those soft parentheses and know to the left, it can go to -infinity, and to the right, it could go to +infinity. I think that has the most meaning for me of how you want to label the domain. Where the range does have a limit. It looks like the lowest it gets is 2, the highest it gets is 4. So you could write it where y is greater than or equal to 2, but less than or equal to 4. I personally prefer that bracket. You need the strong square brackets because it's not going to go below 2 or above 4, but you can choose what you prefer. Okay? That is it for domain and range videos for tonight. We're going to practice this with an activity in class tomorrow. It's going to be great. So make sure you have some nice notes so when it's time for the activity tomorrow, you know what you're doing. See you then.